I will try and not to sound too tired and unenthusiastic, uh, but going to work and everything and coming back and being busy in myself, looking at the pinout on this Yamaha A3000 Sampler, not this one, but this one. And what I'm aiming to do is make a breakout box to control the knob movements and also display the LED lights on this rack blanking plate which I bought, which I was going to turn into a patch bay for audio and MIDI. And basically I've got a potentiometer on here, an analog one, and I made the box for this unit to fit in. This unit is going to comprise, because I have some indentations here made that line up with the knobs, encoder knobs here, and basically I'm going to have 3 push buttons in each location, and the top one will be the push feature of the data encoder. The left will respond to left dial movement, and the right button will respond to right dial movement on each according encoder. Okay, so what I'm going to do is make a breakout box. I've already made an adapter to, well, an expansion, let's say, using a 25 pin DB connector, DB25 may I add, and this goes in, fixes in, and it will have that 25 pin connector on it. I have actually put a male on there for sake of testing the wires. So this is of course a DB25 female, which is always present on the hardware, and then we use a male to male DB25 connector like this to patch between the back of my sampler it seems so weird, and the back of this knob dial interface. Well, there'll be push buttons, and I will have LED lights as well going through the circuit, and have LED lights on the fascia here. Not only that, I'm going to expand it to be able to control both of these samplers, and I'm going to have 2 outputs. I'm going to have a double pole, double throw switch to switch the earths over between the samplers, and still maintaining the button functions. And whilst using the button functions, it should not interfere with the other sampler. I'm thinking of using some diodes in the mix there to stop interference, so that the electrical information goes the directions it needs to go, and not running back and forward through. But the I think I will need a triple pole double throw switch. No, is it? Yes, I believe I need 3 connections to jump across to another place. So that's a triple throw, a triple pole double throw. That's correct, because the double throw is on one place. There's a middle place on these, a lot of these switches, and then the other place is the next plane, and I would like one of those where it's a click button like this, and have a middle position on it. So it's got a 1 at the bottom and a 2 ones, but I'll have the 2 ones at the bottom and a 1 at the top, and then when the 2 ones are down, it will be sampler number 2 in this void here, and when it goes to sampler number 1, it will of course be sampler number 1 that I'll be controlling from this control box. I'm going to get around these data encoders and have more speedier control. But you're thinking, oh, you're going to have to push the button like so. We'll go to a page, for example, and a well sort of experienced Yamaha A3000 user would know that if you're going down like dum 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 dum, that's each time you push a button, right? Okay, that's each time you push a button, you're going down incrementally by 1. So really, we want to speed up the process, don't we? We can't keep tapping the buttons like Daley Thompson's Decathlon back on a ZX Spectrum back in the day. Sinclair ZX Spectrum 128K. Yeah, I also did some kind of wacky invention where I actually housed the circuit board of the Sinclair Spectrum into a rack, and not the place that has well, I don't know, oil is it or whatever, or Arabs live in there. That's Iraq. A rack mount piece of hardware, and I've even put the Spectrum logo on it. Yeah, it's got a bit scratched up and bashed up and that, but I made this back in 2013. Those are the joystick ports here that I routed to the circuit board. You can tell what kind of connections they are, and we have again our DB25 connector, and this dial here is to control an amplifier, an audio amplifier, in which I installed inside this Spectrum. I want to talk about this because I actually program music in 128K Basic, and actually get 8 channels of MIDI, and yes, I can connect them to my samplers and actually make music, because I can connect it to one sampler through the MIDI in, and then the MIDI through will go to the sampler below, and I'll assign channels to the corresponding sounds that I want. But there's no point using 2 samplers because I've made tracks happily using just the one. But having 2 gives you more effects options, and yeah, and that is great. So I'll do that. I'll be very inclined to do that actually, and do something quite creative where the samplers talk to each other. We're having different voices, etc., all within the program. But this is the keyboard, which I extended out and and actually soldered this. There's 13 connections on this, and so when we plug, yeah, here we go, plug this. I'm sorry if it's shaky and stuff, because I'm having to look at what I'm doing in between, but I'm trying to sort of fathom where the picture's going while I'm mooching about and plugging things in. But I was playing a game Whizball the other night, completed it happily. I do get beat on it quite sometimes, yeah. I do slip up on Whizball and get messed up and die. And that's the beauty of it. Spectrum was always quite a hard gaming machine actually, but yeah, this is my MIDI beast, and I put an audio amplifier in here, and that's the switch to actually switch the audio amplifier on, and I use that when loading loading games off of a mobile phone, where you have an app that recreates the tape noises based on maybe an 89 to 141, or how many, well, it can't be higher than 128 kilobytes because but yeah, it can't even be higher than probably 100 kilobytes, because the other something 28 kilobytes or whatever took up by some operating features of the Spectrum, so you don't get the 428k on the game, so in the memory, but the memory gets filled up with some of the Spectrum's workings, and it's the way it works. It's a machine, not really a computer, it's more of a machine. Right, so what I've done is been checking the pin outs on this connector, which has got 13 pins on it. I'm going to call pin 1 this one, okay? Sorry about my fingernail state of them, that's probably my best nail. Working in a garden centre with dirty dirt, and working in my own garden and building and making fence panels in my spare time and all that going on. My hands are well and truly absolutely battered, but that's part of the fun, and I don't mind that. I can live with it because I get so much done, and so I achieve quite a bit of things going on. But right, we're going to get to right, we've seen expansion, and also I would just like to point out that I have actually got a crocodile clip on there, and I have used pieces of tape, and I've numbered every single one of those corresponding to the pins working their way across from the top left, and the top left one is pin 1, which is ground, okay, and then it goes all the way across to pin 13, then 14 is on the bottom left corner, all the way up to 25 on the bottom right corner. We've done all this, we've gone over all this like many times in my mind when going through all of these wires and points. Now, how did I test all this? Well, basically I've got some contraption plugged into the speaker headphone output, and I'm using the big headphone socket, but I have a splitter and it's going to a speaker. And basically when these two wires make a connection, the speaker will sound, and aliens are coming. The aliens are coming. Right, okay, so yeah, because basically I'm using a saw wave and basically got LFO speed set to 70 and the pitch. Let's up the pitch. Let's just ramp up the flying saucer shenanigans. Oh, that's very good. We'll do Pac-Man later. Okay. Yeah, it's pretty similar. Right, so basically on this picture here, you can see it looks like the solder joins are actually together, but it's not. It's just crappy image, or it's dirt and grit on there, whatever. Now this, basically this bit here, I need to open up my other image down below. Here we go. Right, so we have that 13 pin connector, which is like here, yes, which I have put in pin number 3. Now on the image here, that looks like the earth and pin number 8 are joined really, so, but we'll go through this because we'll do some testing. Now with these data encoders, there is something very mysterious and can actually get you quite mixed up when it comes to testing to find out what pins correspond to the circuit on this, and the data encoders, and what pin they take up. So basically what I'm going to do is test this one, right, and then I'll tap it on earth and the other one. No, and there is absolutely nothing. But now if we adjust this data encoder left or right, just one click, when we test earth, it's making noise, and also on the far right pin. So basically all 3 of these pins, I'm going to do it with my right hand because it's more dexterous, and I was doing it with my left, and that's so a little bit sort of mixed up for me. But yes, it's the left one I'm testing for, and it's making a noise, but the earth is also rocking, and so is the right pin. But the reason why this is because every other turn of the dial is shorting out all of the pins and connecting them all. So test the left, test the middle, the ground, nothing. Test the right click, nothing. But we do it again, and I've gone down again, and so that's every other click. So 1, that's always going to work. So his earth is connected and the far right one is connected. Now it's shorting out every other click, but that's just the way that these data encoders work. But I have tested ground and knocked the left pin and just kept tapping it, and the numbers, while the Yamaha A3000 over there was switched on, and while it was switched on, I was tapping those pins together and actually getting data increments going down from very nicely and smoothly. And so I thought, right, this is going to prompt me to make this patch bay thing. Well, it's not going to be a patch bay anymore. It's going to house these buttons, which are going to control the knobs and also their push feature, and also show an LED light that corresponds to the page that I'm on the corresponding sampler that I am going to be controlling. So the lights come on on, yeah, we go, the LED lights on different pages. So yeah, you can see like there's 4 on that one, 4 on that one, but 4 again. So we go down just 1. There, yeah, well this one's got 2, but I think that's because we're on MIDI. But every page, yeah, has got a different set of lights that can be controlled. And so it's going to be quite fun. But I'm also wondering now, because I found that on this side here, this corresponds to, and I've numbered them all as you can see. So basically this here is this. So as you can see, the pins running up on the right hand side, the bottom one, which I call the encoder ground, and then you've got the second pin is numbered with a red number 2, and the red number 2 is here, and then 7, and then as you can see, the pin layout on the side of this encoder basically is logically 2, 7, 3, 8, 4, 9, 5, 10, 6, 11, and we've got the same pattern, 2, 7, 3, 8, 4, 9, 5, 10, 6, 11. And so that's nice and logical in terms of looking at running across. Now all these connections which I have numbered here, yes, so they're appearing on the top of the board here, but realistically speaking, that every single number that you see here, because you can see numbers corresponding to the LED lights, now they're going to be, and I suspect of course they're going to be on this side, on the 11 pin socket. That's the 13 pin socket. This one, I'm pointing my finger in the wrong area. Anyway, it doesn't matter. That's the 13 pin socket. That's the 11 pin. And I think the 11 pin controls the knob push for each knob, as well as it does all 5 LED lights. That's 10. That's 10 features plus an earth maybe. So that makes the 11 on that side. So that makes sense, because we have a push, an LED, push, LED, push, LED, push, LED. That is 10. Takes up 10 of those pins, and then the last one's going to be an earthing or grounding or something to that effect. And I'll find that out on the board as well, using my UFO sounding device. Yeah. Oh dear. Yeah, it's getting a bit yeah, off on a tangent. But I did take a couple of pictures off of the internet, which I have used just for sake of purposes. But this is my own photograph of my butchering of my A3000 encoders circuit board. As we can see, oh, we're seeing double now. But where that connection is, which doesn't look too clever, let's say it's there, you can see actually that the solder's not touching, so it's just a mess. But on the image there, it actually looks like the connections are bridged, but it's fine. Anyway, so this is quite a, I would call, sort of exciting projects that I think I'm working on. Oh, I had to basically use this black wire to earth everything across, because when I replaced one of the encoders, which is the butchered one, I ended up overheating because of these 2 nasty clamps. As you can see, like, I think I need to like push that down a little bit more, because that knob always plays up, and when I push down a little bit more on it, it seems to be more secure. I think it was holding down into place a bit better, but that's doable. I'll be very tender and careful. I might use like a magnifying glass, and I think I kind of flathead screwdriver or pliers. Actually, I'm going to use my small headed pliers actually to bend. Just bend it, push it, and use the top to push it down. Yeah, that'll be fine. Talk, so positive self-talk and constructive talk is always kind of very helpful because it enforces self-belief, no doubt. Anyhow, we haven't got it plugged, but there's no point in like really doing anything with it because it has no encoder board in at the moment. But if I was to say hijack these ribbons after getting all of the pin outs, because I've got the 13 here, I have the 13, and once I get the 11 I'll be able to take these off of the motherboard and then hijack onto these wires and join these wires onto them and then tape them up. Or let's say, I think we need to like have some heat shrink jobbies on this one, some heat shrink tubing, but I will like connect it all and get it going, running, keep the cables separate from each other from touching, and try the pins out on the DB25 connector and do some testing and actually bridge some connections and see how the encoders will operate. But you can, I think, control the Yamaha A3000 still. I'm not totally sure, convinced, but we'll see. We'll go into okay. Right, but how do we get that to go to an effect output? I don't know if we can do it. It's a bit esoteric. No. And now I'm pushing all the bits and bobs and they're all dropping off on the floor. Put it on nice and carefully. There we go. Oh dear. Fun, isn't it? Taking things to bits. This is, for those who do not know, this is a floppy drive emulator, and you just plug a USB memory stick into it that's been formatted on a PC, or you can format it. You can't format it on this. You have to format the memory stick on a PC, and it gives you then the 100 partitions basically, and you have to let's see, what do we do? Where's that? The buttons. We're getting nothing. Is it go? Ah, the reason why that is because I have no USB stick plugged in. So we'll go around here and find one, because I'm sure I have one. Well, that will do. It's formatted, but it belongs to the top sampler. But now that goes in, so that controls. See, there's your 100. Okay, if I press that one, it will go down to 0, and that one will go down to 0. So basically the left controls the tens and the right controls the units. There's no need for that 0 there at all. But if it was a different logic circuit in there, then it would show the numbers up as from 1 to 100, just to make you think that it was, because the folders are named 1 to 100, but whatever. Some things start with a 0, start MIDI. MIDI starts from 0 to 127 or 1 to 128, depending on what system you're using, and it's the same thing, same principle I guess with this USB floppy emulator. Don't be fooled by the -1 of it all, but you'd think that yeah, you're using floppy number 1, but it's actually 000 on this, so that's number 1. So after doing some hardcore mapping and finding out where all the bits and pieces go, now 12, 13, 14, 15 and 16 here are to do with the underside of, so basically on here where those numbers correspond to are, I have to turn this really, yeah, it's facing the right way because these bits are where the data encoder are, left and right and everything, and these bits here and here I think are to do with the data encoder's push button feature. I think it's actually this one, because this where I found it, it was the push button ground, which is on pin 18. Sorry, well it's on pin 13 on this basically. This is like the underside, so I've had to logically kind of switch it around, but it's there, this one, the 13 pin. But on pin number 13 it's the push button ground, and on pin 17 it's the LED ground, the LED lights. And yes, found the rails using the UFO, and we did very well, the UFO and myself. But yes, finding out all of the positions, I have yet to find out what's going on the left hand side with the 11 pins, but that will be fun. Another fun thing that I found as well was when putting what pin was it? I think it was, let's say, one near the top. There we go, and then touch one of the sides of the LED lights. Oh yes, here we go. Ah, don't fall. Right, let's get it back up, and we'll just touch the, see, the LED light comes on, and or I found it's ground. It's very loud, isn't it? But then touch the other side of the LED and it comes on, because you're passing voltage through it. And if I adjust the volume on the sampler, it also adjusts the brightness of the LED light bulb too, which is quite fun. Let's do some crazy experimentation, like with circuit bent Yamaha A3000. There we go, look, dimmer. I wish I had a hand free so that I could adjust the volume, unless, let's get creative, because we can adjust by using amplitude instead and have a slower LFO, and so we'll do that 25, and then we'll go for amp, and then we'll give it a very wide range. Turn the volume up a bit, and the speed right is on 16. So basically what we should now get, hopefully, we'll have a pulsing LED light bulb which goes from dim to bright to dim to bright, and the sound's probably going to do the same too. We'll see. It might be quite slow. I might have to adjust the speed. Come on. Oh dear. Okay, so that's the ground side. Now let's find the LED light. Grr. And grr. Hang on, let's do this. Okay. That's quite interesting. It's obviously absorbing a lot of the oh my days, it just gets better. Sorry everyone that I dropped